It is called as net present value method. This is one of the most important method in the entire investment appraisal problems. Okay, so ensure that you understand this thoroughly. So we'll start from the theory. So theory here is the net present value method is a capital approach focused on incorporation of discounts on the after-tax cash flows. Okay, so we are going to apply discount factors and we are going to get the answer here. So it's going to be discount factor on after-tax cash flow. This is a model that facilitates accuracy in valuation because it follows the rule that states that all positive net present value have to be accepted while negative net present values must be rejected. However, in cases where funds are limited and an enterprise cannot accept all positive values, the high discounted value, okay, the high, I think we'll put like this, high NPV should be selected. Okay, so the concept is very simple. NPV should be higher the better. Okay, if it's a negative, it means it's a loss making project. If it's positive, means it's a profitable project. If it's the higher the NPV, it means it's a higher the profitability. So that's about the NPV method here. So let's look at the sum and we'll work it out. So we'll work out for this sum. So you can work out the sum in any manner you want, whether you want to put the years this side or if you want to put the years this side, however you put, still the answer is correct. Okay, for small problems we usually put the years on this side itself. Okay, and for lengthier problems we usually put the years this side. Okay, so it is only up to us to put the years. As this is a small problem, we will just follow the approach we used for payback. Okay, the similar payback table we'll use. So we don't need cumulative, we can remove that. I think rather than copying this, we'll copy. Okay, we don't need to copy anything. I think we should start it as it is. So this is our cash flow. Okay, the unique thing about NPV is we have to have definitely the 0th year. Okay, we have to have the 0th year. So 0th year is a definite year. Okay, first you have to put that. So in the year 0, you should also put the investment that you have made. Okay, any investment that is made is a cash outflow, right? It's a cash outflow. So if you want, I'll just put it here. So this year around it is outflow, and thereafter it is inflow, right? So this is cash outflow or inflow. Any outflow should be marked with minus symbol. Okay, so that is a definite. You should mark it with a minus symbol. So next we have to find out the discount factor at 10%. So the 0th year will always be 1. The next year would be the previous number divided by 1.1. Thereafter copy it and just paste it for all the other numbers. You got the numbers. We don't need so many numbers after decimal. We can reduce them. So we got this also. So the next one is DCF. So DCF is multiply your cash outflow into the DCF, sorry, the discount factor, you will get the DCF. Do the same for all the numbers. Okay, do it for all the numbers, and if you require, remove the decimal. With NPV problem here. So we have done basically the same numbers in the previous problem, so we'll just copy it from there. So we have typed the numbers here. And our next step is to find out the NPV for this sum. So we'll start here. So to do a NPV, we have to have certain numbers which are additional to payback sum. So first we have to get the 0th year. Okay. And the 0th year, it is a cash outflow because you are buying the machine, right? So the cash is going to be an outflow. So the outflow should be marked with a minus symbol. So it is minus 12,000. The next one would be the other years. The other years, it is a positive cash inflow. So they are cash inflow and they have to be marked with a plus symbol, right? So the outflow alone is a minus symbol. Okay. In an answer, you just need to work out these part. You don't need to put it as a cash inflow or outflow. This is only for our sum sake I'm doing it. So the next one would be the discount factor. The discount factor at 10%. So the first year discount factor is always 1. The next year discount factor would be the previous number divided by, as it is a 10% discount factor, it is 1.1. So copy it and you'll get the answer. So that's about the numbers. You have got the numbers. Either you get it from here or you get it from the the present value table. So present value table, the numbers are here. Okay, you can get it from here also, the same numbers. Or if you want, you can use the online calculator or normal calculator. It's better you use a physical normal calculator for getting the answer. So the sum would be like 1 divided by 1.1. So if I press equal once, it is a first year discount factor. This is a first year discount factor. This is a second year discount factor. Third year, fourth year, fifth year. Okay. So we got all the numbers that are required. So from here on, we'll move on to the DCF. So DCF is nothing but discounted cash flow. So discounted cash flow would be the cash flow into the discount factor. So it would be the same for all the years. Okay, it is going to be a computation of multiplication. Multiply cash flow and your discount factor. At the end, you will get your NPV. Okay, net present value. So the net present value would be the addition of all the numbers, including the minus number. So you got it. So it is a positive number. Okay, so you can put a suggestion like this: as the NPV is positive, it the project should be invested. Okay, so hope you got the idea here. It is a simple problem only. So the first year alone, the cash outflow should be shown. Okay, 0th year you have to show, and it is a minus symbol. The discount factor is 1. So usually people might forget this this single line, and usually they work it out. So this is a very important number they have to remember. Okay, and while adding, you have to add all the numbers, right? You have to add all the numbers. So you will get a number like 1850. As it is a positive number, you can invest in that project. So that's about this problem. We'll move on to the next one, next NPV sum. So first we'll get the numbers for this. Okay, it's the same problem. You can read the question by yourself. So let's get the numbers. So again, what we require discount at just a second. Okay, so here we have, so we'll start with this sum. So you can read the question by yourself. So the investment is 1,40,000 and these are the cash inflows 40, 40, 30, 50 and 10, and it has a scrap value. So 10 plus 10, 20,000, and the discount factor is 12%. So we'll start from the discount factor. It is 12%. So then we have to get the DCF, discounted cash flow we have to get. So for every NPV sum, we need to start with the sum with 0. So the 0 would be the cash outflow, which has to be 1,40,000. So the 0th year discount factor is 1. Thereafter, it's going to be the previous number divided by 1 point the discount factor. Discount factor here it is 12, so it is 1.12. You got the number there. Again, copy it, paste it, paste it, paste it, and paste it. So an alternative approach we have already seen. I will just show you once more. Use the calculator. So calculator would be 1 divided by 1.12. So if I press first time, it is first year discount factor. This is second year discount factor, third year discount factor, fourth year, and fifth year. Okay, so that's about the discount factor here. So now we'll get the DCF. So we got the number. So from there on, we can just multiply the numbers, we'll get the answer. So multiply the cash flow into the discount factor, you will get the DCF. So we got the DCF. Now what we'll do, we'll get the NPV. So our NPV would be a negative 7920. Okay, so as it is a negative 7920, our suggestion would be, as the NPV is negative, comma, it is better not to invest in the project, right? So that's about the suggestion here. So hope you guys got an idea. Okay, if an NPV is negative, we should not invest in it. So we'll move on to the next one.